Hi, today we'll go into one of the topic known as molecule and ion. So in these topics, we look into different types of substance, including molecules, ion, compounds, cation, anions, and also acid, base, and hydrates. So what is an ionic compound? So ionic compound consists of a combination of cation and anion. So as you learned previously, cation are those ions with positive charge, anion are those ions that come with negative charge. The formula is usually same as the empirical formula. Like I can just give one example, like you have NaCl. So sodium chloride, we would write Na2Cl2 because the formula show that NaCl will be in the simplest ratio. So it's shown that it's an empirical formulas. The sum of the charge of the cations and anion in each formula unit must equal to 0. For example, the NaCl, sodium chloride, as you can see the charge Na plus, Cl minus, so the net charge will be 0. Another example, let's say I have barium chloride. So barium is 2 plus, chloride is 1 minus, so the total charge is 2 plus. And over here we have 2 minus, so the net charge will be 0 as well. And these are some of the structures of ionic compound. As you can see, this structure is sometimes known as the lattice structures. So lattice structure of any ionic compound will be something similar like this. As you can see here, the red dot represent the chlorides and the white color represent the sodium plus. So we have an ion, which is a cation, and ion, they are held together by ionic bonding. Okay, in this slide, you will see a periodic table. So the green color label on the left side is known as a metal. So all these are metallic elements. And the right side on the periodic table, you do see the one with blue color. All those are known as a non-metal or non-metallic elements. So the most reactive metals is labeled in green color, and the most reactive non-metal, which is labeled in blue color, will combine and form ionic compounds. So the reason under this is because the metal will tend to form a ion known as a cation, which is positive charge, and the non-metal will tend to form a anion known as anion, which is negative charge, and these two will actually attracted together and they will form a compound known as an ionic compounds. Okay, here we have three example ionic compounds. So the first one is known as aluminium oxide. Right, aluminium oxide is comprised of aluminium 3 plus and O2 minus, known as oxide. So I'll just label that aluminium oxide. Alright, as you can see that the net charge for the left side will be a 6 plus or plus 6 because aluminium 3 plus, you have two of them, so total is plus 6. And for the oxide, we have 3 oxides, so the total charge will be minus 6. So plus 6 minus 6, the net charge will be 0. As I mentioned in the previous slide, all the ionic compound that will show a net charge of 0. So the next example we have is known as a calcium chloride. Calcium bromide. So calcium is 2 plus and then bromide will be Br minus. So the naming for this will be a calcium bromide. The net charge will be 2 plus and the net charge for the ion parts and ion parts will be minus 2. So the net charge will be once again plus 2, minus 2, 0. And the last example we have it here will be known as sodium carbonates. So we have a sodium plus and we have a carbonate CO3 2 minus. So this is known as a sodium carbonates. So the sodium we have 2, so the positive charge will be at plus 2, and then carbonate we have 1, so the negative charge will be minus 2. Once again, the net charge will be 0. Okay, we move on now to the next part, which is the very important part in these topics. They call it the chemical nomenclature. Okay, ionic compounds. So most are binary compounds, some are ternary compounds. So what is the meaning of binary and ternary? Binary means two. So this binary compound is comprised of only two elements. So you can put a remark there. This is only comprising of two different elements. While for ternary compound, they will be made up from two or more different elements. So as you know, ionic compound is a compound that bond two ions together we have a cation and anion bond together. So often is you will see a metal and a non-metal in the formulas. Alright. And since we have anion, which is come from non-metal, the ending part of the naming for any compound will end with IDE. Like we have several examples here. We have the first one, barium chloride. Alright. The next one, we have a potassium oxide. And we have a magnesium hydroxide. And we have another one, which is a potassium nitrate. Okay, many students are struggling with this kind of naming on the right side or even writing the formula on the left side. So I will show you how to come up with the formulas and also write the names. Okay, so like for example, barium. So barium is come from group 2, so it's actually made from barium 2 plus, because any group 2 element that will form a 2 plus. And the chlorine is come from group 7, so it will form 1 minus, so you call it chloride. So you just put the two names together, we have a barium chloride. And the next example is a potassium oxide. Potassium is come from group 1, therefore it's K plus. Oxide is O2 minus. Oxygen is come from group 6, it will form O2 minus. Magnesium, similar with barium, is come from group 2, so magnesium 2 plus. Hydroxide is one of the compound anions we have, in which case the formula will be OH minus, right? And the last example we have is a potassium nitrate, which is known as a K plus, so potassium group 1. Nitrate, once again, another compound ion. The formula is known as NO3 minus. Alright, so when you combine these two cation, anion together, you will get the formula of the ionic compounds. And be careful, sometimes you will have to use the brackets, as you can see in the magnesium hydroxide. Alright. Okay, next move on to special groups of metal that are known as transition metals, as the one labeled in the green color here. Sometimes they call it the D block elements. Alright, so they call it transition metal or D block elements. And they are metal, so once again they will be forming cations. So this group of metals, they will forming cation. But it's important to note that the cation that come from this group, they come with different charge. Alright, as you can see in the left side and right side here, it can be +1, +2, +3, +4, even +5. And to put the charge in the naming, so we are not using number, but we are using Roman numerals. Alright, so let's look at some of the very popular example here. Okay, like for example, iron. So we have an FeCl2. Alright, the naming for this FeCl2 will be iron 2 chlorides. So the Fe is come from the group here. As you know, it could be many possible charge. It could be 1 plus, 2 plus, or even 3 plus. So how do we know that the iron is in iron 2? Okay, so in order to work out the charge for iron, so we just move on to the anion parts. The anion part is actually a chloride. So chloride is not come from the middle groups. It comes from group 17 or group 7. So it has a fixed charge, which is a -1. So we know that Cl must be Cl minus. So the iron must be iron 2. Why? Because as you can see, there's a FeCl2 there. The 2 here is not come from chlorine. It's actually come from the iron 2. So it's iron 2 plus, and with chloride minus, then we cross over to balance out the charge, we have FeCl2. So the naming, you have to put a bracket 2 to indicate the charge 2 plus. Okay, we have another iron here also, but this time you can see it's FeCl3. So the 3 doesn't belong to chlorine, but it's actually come from Fe, iron. So the naming for this, you will put iron 3 chloride. Alright, so it's actually Fe3 plus, Cl minus, so you cross over, so you get FeCl3. Right, the next example we have is known as chromium sulfide. Okay, Do I need to put the numbering? Yes, once again, you need to put the numbering. So the chromium is once again come from this group, okay? And the sulfide is a come from sulfur. So sulfur is group 6. So from there, I know that the sulfur will have a fixed charge, which is 2 minus. Because group 6, they will accept 2 electrons, they will form 2 minus. So I know that the sulfide will be S2 minus with the fixed charge. Then how about chromium? So then we figure out the chromium. As you can see, a 3 and 2 here. The 2 is come from sulfide. So the 3 must come from chromium. So once you cross over to balance out the net charge, we have chromium, Cr2, and then we have S3. So the naming will be known as chromium 3 represent Cr3 plus, sulfide represent S2 minus. And here we have more example. As you can see, we have chromium. So chromium, here they give you some of the possible popular charge for the chromium. So we have chromium 2 and we have chromium 3. Copper, we have copper 1 and we have the copper 2, which is quite popular. But sometimes to take note that because copper is very popular, so instead of calling copper 1, copper 2, sometimes we use the old naming. So sometimes we call it this one will be known as your cuprous. Then this one you known as your cupric. So sometimes we call it cupric sulfate, cuprous sulfate. Okay, gold. Gold is Au, so we have gold 1, we have gold 3, iron, we have iron 2 and iron 3. We can use the same naming, like we can put it ferrous, and this one we can call it ferric. Alright, and then we'll move on. We have lead, lead 2 and lead 4. Right, and here we have some practice for you to try on to test your understanding. We have 2 from iron, 2 from copper, 1 from tin, and 1 from lead. So the first one is FeCl2. So FeCl2 is known as iron 2 chlorides. So if you recognize the one that I circled, those are the elements come from transition metals. As what you learned previously, any transition metals you must indicate the charge. In the naming, you have to use the brackets. As you can see in all these examples here, they put all the brackets to show the charge. And they are all positive charge. Alright, so the first one will be iron 2 chloride. The second one will be iron 3 chloride. So the 3 is come from iron 3 plus, 2 is Fe2 plus. Okay, next I want you to figure out what is the charge for copper. Third example and the fourth example. So to do this kind of example, let me show you. Alright, so we have 2 copper compound here. On the left side is copper sulfide. On the right side is copper chloride. If you just put copper sulfide, copper chloride, then you get a wrong answer because you have to indicate the bracket to show the number of the charge. Okay, to work out this one, you work on the N ion first because as I know, sulfide is fixed S2 minus. Chloride is fixed Cr minus. Alright, so what you do next, you need to figure out the copper. Alright, as you can see, the 2 here most likely will be definitely come from the 2 minus here. So this one will be 1 plus. So as you cross over, you will get Cu2S, which is the formula that they give. Alright, so the first example, it should be a copper 1 sulfide. It's not copper 2. The copper 2 is actually on the right side, on the right example. Okay, so look at this example. So the chloride Cr minus. So as you can see, there's a 2 there. So this copper will be in the copper 2 plus. Right? So as you can see, when you cross over, you will get CuCl2, which is known as copper 2 chlorides. And here we have tin 2 chloride. Because chloride 1 minus, the tin must be in 2 plus. And then the last example will be lead. So once again, lead come with lead 4 bromides. Okay.